All right, guys. We've got a request tonight. The young man that I'm doing the GT40P heads for, he had a request. He's a little worried that his older stock 5.0 short block may have trouble handling the improved horsepower. So I said, I can do a demo on deburring. And it's just going to be, I'm going to be talking about it more than anything else, really. I'm not going to be doing anything on this old block. But you can see, as you can see, this block at some point had an issue, and I had to take a piece out of the bottom of the cylinder. Whether it had eaten a connecting rod or whatever at one point, I had to... I'm not even thrilled about the way I did that, because that's relatively sharp right there. Oh, I know why it's sharp like there, because of the way I had to get... Sorry, guys. The way I had to get at it with the burr. Look at that. That lines up perfectly still. And, this block has been around. I mean, who knows when the last time I built this was. But I know it wasn't a stroker because... doesn't have any... the reliefs are the same. So it was a 350. Okay, let's zoom out. So I'm going to show you with a burr, but in reality, a mounted stone is really the way to go. Okay? Any sharp edge is an excuse for a stress riser to start a crack. Okay? And you can see I just went over the bottom of those cylinders quick with a stone. That bottom of the cylinder there has got a strange piece missing, but it doesn't have a sleeve in it. You can see it was overheated at some point. It's got some scratches in it. Okay. Because the stock casting, you can see that line right between those two lifter bores. There's also usually a line in the bottom of the cylinders where the molds fit together. They never really line up perfectly. So you go through them and round all that stuff off. If you take a look at stuff like the caps, every sharp edge on the caps need to be removed. Sharp edge here, right? Think of it as roll of paper towels. All right, how does the manufacturer of a roll of paper towels make it rip where it's supposed to? They perforate it, right? They put stress risers into it. So if you looked at cast iron, well, if you magnify it, it looks like a bunch of holes holding hands, right? But even if you just looked at it with the naked eye, you can see how rough and jagged it is. Any machine surface is sharp. I mean, modern cylinder heads, you get them, depending upon where they're manufactured, are like razor blades, okay? This is definitely an older... This is one of my older blocks because the oil passages are stock, okay? I usually modify them to get better flow in and out. Right, there's the other hole. Yeah, these are still stock. So this is one of my much older blocks. Who knows how long I've had this? But in reality, it was probably built in somebody's car for God knows how long. And I wound up getting it back. Because that happened to me with a couple engines. That's what I think this was. I think it was a 350. But I do specifically remember that one. That one had a big piece missing out of that corner. And it was all jagged. And I'm like, you know what? I'd rather take it all out and round it the best I could. I'm not really thrilled the way I rounded that. That's still sharper. But obviously it didn't crack. But I doubt this was a super high horsepower engine to begin with. So, in reality, you take the mounted point and everything that has a sharp edge on it, or where the casting doesn't line up. Can you see? Well, that's not bad, but you see that little notch right there? Perfect place for a crack to start, right? Now, what a lot of people don't understand, and is when there's no place for the crack to start, the iron will flex a lot more without cracking. Okay? Now, a 5.0 Mustang has got a block cracking issue where, supposedly you get around 500 horsepower and the block breaks in two, right along the center of the engine. Now, most people don't know why that happens, but I think I have a pretty good idea. All right, it's got a 50-ounce harmonic balancer on the front. Okay? Now, Ford cast crank is pretty tough. It's got good size mains, good size rods, journals. It's a relatively stout piece, and it's a short stroke, right? But when you get 50 ounces out of balance hanging off the front, what do you think that's going to do to that crankshaft, especially when it comes near the harmonic frequency, or we should say the resonant frequency of that crank, right? Resonant frequency is pretty cool. If you don't know what it is, look it up. What happens is those harmonics will start to make that whole crank do this in the journals. Okay? And if it's at the right frequency, those harmonics will get bigger and bigger and bigger, and the amplitude will go up and up and up until something fails. Lots of times it's the crank that fails, or at that point, the block itself could fail, because once your crank is flexing, I mean, think about a pencil. Take your thumbs and push on the middle of a pencil, and then push it the other way. Now do that 7,000 times a second. Something's going to give. The loads, the bearing loads, go through the roof. Okay, that's where they get caps start walking. Think about walking a cap, right? You've got the load of these two fasteners holding the cap down. In reality, you're putting enough force down on that cap to stretch out these fasteners so the cap actually doesn't have any load on it anymore. It's not against the block, right? And that's where you get cap walk. You're actually stretching out the fasteners. Not good, by the way, okay? Because when a good quality fastener like these main bolts are torqued, they are actually stretched a certain amount. They are not stretched to their yield point, okay? That's a different different way to use fasteners. These are reusable, okay? If we put torque to yield bolts in here, and we would set it at a certain amount of foot-pounds, with lubricant or without lubricant, or with washers, without washers, you have to go by the manufacturer's specifications, okay? Let's say we use torque to yields on Mikey's 5.0 Mustang because we had problems holding head gaskets in it. And, you torqued them to like 75 foot-pounds or whatever it was at the time. And then you have to turn it another quarter turn, and it doesn't matter what the foot-pounds are. Well, that quarter turn is stretching the bolt to its yield point. That's why when you take those head bolts out, you throw them in the garbage, because they don't snap back to their original length. They've stretched to the point where they're at maximum load. I don't know if I said that properly. They've stretched to their yield, and they're done at that point. They're very strong at that point. But if you went and torqued them more, your strength goes way down. Okay, let's look at the other side of the block. Okay, you can see this was lightly done, you know, who knows how many years ago. But I didn't radius the edges on the lifters. I put a little bevel on the oil drain back holes. Some people will say, oh, that's bad, you'll get extra oil down there. Well, I'm willing to bet this was a flat tappet motor, so I wanted a lot of oil going down to the lifters. This is definitely an early block because I usually lower these oil passages so we get more oil on timing chain. I'd rather have the oil go down the front and the back. You can see I did do this oil drain back hole. All right, not great, but I did do it. And every place a crack could start. Water passages, I usually use I put an edge on these as well. I can't think of the name of the damn thing. Just at the very top of all the fastener holes. Throughout the entire block, even the outside of the block, right? Everything on the outside of the block would be the same way, right? Outside edges, the casting lines and so forth. You take it all off. Take all of it off. Okay? So when you're what are you trying to accomplish? What's really the high and low of spending maybe 5, 6, 7 hours going over a bare block? And by the way, when you're done with it, you got to wash it like crazy because the dust gets everywhere. You got to get all the, you know, the oil journals, the passages. The grinding dust gets everywhere. You can see this engine's had, I moved something near it and all grinding, aluminum grind. Oh, we put that manifold on here. That's what happened. And that manifold had aluminum grinding duster on it. Everything, you know, you pull all the oil galley plugs and everything out of it, and it needs to be thoroughly washed after you deburr. What I used to do is I used to deburr them, you know, pop out the well, I didn't necessarily pop out the oil galley stuff before I sent it to the machine shop. But I always would clean the snot out of it, and then I would always pay them to boil out the block anyway. All right, as you can tell, I'm in my usual state at the end of the night, toast. I know what else I have to talk about. Hold on. Okay, I remember what this block is for. This was Mikey's old, the People's Truck engine. The People's Truck was an experiment. All right. Just junk I had laying around. Right, 11 to 1 forged TRW. Notice we're talking about the stress risers and so forth. Why would you grind and polish the beams on a rod? Same reason. Actually, multiple reasons. No place for a crack to start. When you go through your engineering books, right, a polished surface like that versus a cast rough surface can add up to 50% strength. Now, like Tony Persico says, that's a waste of time, Charlie. Those rods will go 8,800 RPM stock. Well, after I waste some time and put some better bolts in them, these had Pioneer bolts in them. All right, I resize them by hand. I grind and polish the beams. All right, they've all been balanced. This one was obviously the lightest of the bunch because it didn't get any metal taken off the bottom. Every edge gets deburred. Okay. When you fit them for bolts, this needs to be machined. This plateau here has to be dead flat. Let me see. I've never seen a set of rods get redone where they ever machined that. Never. But when Charlie does them, I machine that by hand. And I measure it and I make sure that's dead flat, because if it's not, and you load this bolt, the head of that bolt has more strain on one side than the other side. Okay? Not good for a fastener. If you take a look, maybe hard to see, but you see that interface where there's a big notch taken out of the rod? I go in there with, when the bolt's out, go in there with a pencil grinder and you grind a relief on that. There's actually grinding on the inside of that. I don't know if we can see them, or if these may not have got that. That may have been a later set of rods. Yeah, these are not perfect. You can see I didn't, these may have been a really early set of rods. Because I remember I stopped using Pioneer bolts after a while too. Not that I ever had a failure with the Pioneer bolts. I never did. So just a quickie on what this engine was, right? It was all junk that I had laying around. So these were probably half prepped rods and I threw them in. Right? I had this set of 11-to-1 pistons. I had this 30-over block, which was probably already used. That's why it's in the shape it's in. Set of giveaway heads. They were like 307 heads with the little tiny valves, 172, 15s. I opened them up to 194s, 15s, put some old valves in them, ported them. Tiny, tiny ports. I used a little tiny Holly intake. The Dash 38, I think it was. It's got little tiny runners in it. Ported it, made a special spacer for it. I used a Comp 252 flat tappet hydraulic, really short cam, because he wanted something to tow bricks. So the entire thing was built for torque. Small intake, small runners in the head, of course all ported. Set of headers, H-pipe, Hookah aero chamber mufflers, Holly, annular discharge carb. I want to say 650. So, oh, and you know what else we used? I think we used those. No, it wasn't those. I used my Crower. I used my Crower roller rockers 1.65 to 1. I still got them because I got this engine back after all the years when the truck finally got chopped up for parts. Well, steel shim head gaskets. Now, if you think about it, right, it's 11-to-1 pistons. The chambers on 307s are about 70 cc's. So it's got some decent compression. It's got a super short cam with high ratio rockers. The cranking pressure was, I want to say 220 plus. It was a bear to tune. An absolute bear to tune. But that thing ran so much better than it ever should have. He's got one good story where he's on Jericho Turnpike and he stops and this black guy pulls up in a Cadillac and he goes, you got a badass big block in that, don't you? And Big Mike's a freaking monster, right? He just looks over and he just smiles. He goes, no, it's a little small block. He goes, man, don't you be bullshitting a bullshitter. I know. I shouldn't probably say it with a black accent, but that's just the way Mikey would said this story, so I'm going to repeat it. Hopefully I don't get in trouble for that. But it was hysterical. So he's like, I know that's a badass big block in there. He's like, nope, it's not. But yeah, it used to fly. He used to put a freaking pallet of bricks in there, and he said it didn't even notice the bricks were in the back. It was actually fairly good on gas too. It did not like the summer months. The compression was too high for that. You would have had to run high test in it. I think you actually did have to run high test in it in the summertime. But it was an experiment that small ports, high compression, high velocity, and even with that ultra short cam, it had no problem pulling 6,000 RPM. All right, guys. 20 minutes in already. So, without any exaggeration, I used to spend a week doing a set of really good rods. You grind them, you deburr them, you machine them flat for the bolts, both ends. I usually use a needle file doing that. And you got to use a caliper to make sure they're dead flat, right? Even the top of the bolt hole needs to get radiused because the newer fasteners have a radius under the head where the original GMs are relatively square. Okay, you put it all together, you have to torque it with the proper lubricant, whatever the manufacturer states, right? And you have to torque them more than once. Then you got to make sure they're perfectly round within spec. Which, if you're doing it by hand because you're broke and can't afford to bring them to the machine shop, you may be working on these for a long time to get them round. Ah, yes, all the joys of being broke when you were young. But what can I say about them? I was so nuts. I used to get them within 1/10 of a gram. 8 rods within 1/10 of a gram. Now you're going to say, somebody's going to say, well, Charlie, you screwed up the whole balance of the engine. And you make a point. We took metal off the rods, right? You changed out the pistons from cast to a pretty damn heavy forged, right? Right then and there, your balance is completely screwed, right? And then if you do your deburring all around your crank, you're throwing that out a little bit too. And a lot of those GM cranks are sharp. There's sharp edges everywhere on them. They all need to be gone through. Well, I also did a balance experiment once. My brother's K5, we had a couple engines in that. One of them was a crappy engine. It was a 60 over 350, and it had a sleeve in it. And I think when I got it, it had a bad piston or something. And of course, we had no money. So I was able to get one 60 over cast piston we thought would match. Well, that piston was 120 grams heavier. And I remember I didn't even think about lightening it. I'm like, you know what we're going to do? We're going to put it in and see if we can feel it vibrate. Well, guess what? We beat the snot out of that thing. And even at, I remember what that engine was. It wasn't anything great. I think it only revved to about 5,500. But it never had a vibration problem. Never had anything like that. So I don't even know where I'm going with that, guys. But thanks for hanging out. Thursday night. Looking forward to the weekend. Happy St. Patty's Day. St. Patty's Day. I should have a beer. All right, guys. Have a good night.